are given two capacitors that are parallel to each other. We've got two terminals here, A and B. The VAB, the potential across your A and B, is 110 volts. This is a parallel plate capacitor because of the fashion of the diagram. 20 nanofarads. Let's, by convention, name it as C1. And this one is C2. Okay. The first question is, what is the total charge? The total charge from C equals Q over V, we need our Q. Manipulating our equation, we will get Q equals CV. Now our C, because it is parallel, what do we know? If it's parallel, we add or we reciprocate. Do we add or we reciprocate? We only add. Okay, so if we add, because we only have two capacitors, that would be your C equivalence or C total. C equivalent, C total. Okay, now 20 nano plus 50 nano is equal to 70 nano. That's your C equivalence. C times your V is 7.7 microcoulombs. That's the total charge of the system. What about the charge on each capacitor? So if it's on each capacitor, we identify the capacitance of each capacitor. So for Q20, we have C20, and for Q50, we've got C50. So 20 nanofarad times your 110 volts. That's 2.2 microcoulombs. Same is true with your 50 nanofarads. Multiply it to your 110 volts. That is 5.5 microcoulombs. Okay. Next one is a total energy. Total energy. You can have 1/2 CV squared. You can have 1/2 QV. 1/2 QV. What's this? What? Oh, okay. You can have any of the three, okay? Just use the one that is really convenient to you, okay? The one that is deemed the easiest for you. So we have our capacitance, we've got a total, so we're going to be dealing with it with the total counterparts, the C total and the V total. Now, the C is 70 nanofarad, as we already discussed a while ago. The VAB is 110. Plug it in, you'll get 4.235 times 10 raised to negative 4. Okay? Sig fig matters, you can have 4.24. That's okay as well. Okay? Now for you each, the energy on each capacitor. So if it's each, we identify the each. 1/2 CV squared, your C would be 20 nanofarads, not the equivalence, your C would be 50 nanofarads. Plug it in, you'll get 1.21 times 10 raised to negative 4 joules. This one as well. You, of course, must follow the sig fig rules, okay? I just want to show you so that you know how to round it up or when to round up, or when you have the given multiple choices, it's easier for you, because sometimes for the multiple choices, we just say, oh, it's 3 times 10 raised to negative 4. Okay, so I want you to see, maybe it's 3 times 10 raised to negative 4 or 4 times 10 raised to negative 4. What would it be? So you just have to cut it depending on the sig fig. But problem solving, sig fig matters all the time. Okay, but let's say E. What's the V across? Since they're parallel, your VAB is equal to the V1 equal to V2, which is V20 and V50. Still 110 volts because it's parallel.